So today we're starting a new chapter that will explore the Pythagorean theorem, but before we can start using the Pythagorean theorem, we need to make sure we are experts at both square roots and cube roots. So today's lesson is all about finding the square root of a number. So with a new chapter comes new vocabulary. So square root, most of you can find the square root, but it becomes very difficult to explain what that is in words. And a square root is a number that, when multiplied by itself, equals the given number or the starting number. And every positive number has a positive and a negative square root, because 16, the square root of that is 4. But it could also be negative 4, because 4 times 4 is 16, and negative 4 times negative 4 is also a positive 16. A perfect square is a number with integers as its square roots. We talked about what the word integer means in class, because if you don't know what that word means, it makes it difficult to understand any part of this definition. An integer is a whole number. Whether it be positive or negative, it's just a whole number. So a perfect square is a whole number, and that's primarily what we will be working with today. This symbol that you guys all know, you call it the square root symbol. Yes, the symbol tells you to find the square root, but its actual name is the radical sign. And the number under the radical sign is called the radicand. And then this symbol right here you read as plus or minus, not positive and negative. So one type of problem is that you just need to find the two square roots of a given number. Most of these you should be able to do quite quickly, because they should be basic multiplication facts that you know. So they say 2 square roots of 49, that would be 7, and negative 7, and these are all the ways we talked about how you could write that down on paper. Then you guys were asked to try these on your own, and you were successful in providing these answers. Negative 6 and 6 for 36, 10 or negative 10 for 100, and 11 and negative 11 for 121. The second type of problem is that you need to find the square root or square roots. Some of them might have 2 because you have this plus or minus in the front, which really represents 2 different numbers. This one's very straightforward, square root of 25. When you have a fraction, you can either see if you can simplify the fraction ahead of time to a whole number, so say it was 28 over 7, that reduces to 4, or you do the square root of the numerator and denominator separately, and you get the answer, negative 3/4, because the square root of 9 is 3. Square root of 16 is 4. And this one, you can pop it into a calculator. Sometimes the calculator asks you to type the radical sign in second. Sometimes it asks you to do it first. It depends on the calculator. But when you do that, it'll give you 1.5, and then you need to put that plus or minus symbol in the front, because this is really 2 answers, a positive 1.5 and a negative 1.5. So yes, you can use a calculator for all of these, but it doesn't know what symbol you're supposed to have at the end or how to take care of a fraction for you. You need to do those things on your own. So you guys did these, and I had a lot of people try to tell me 0.5 on this one. It's easy to try to cut it in half or divide by 2, but the square root is the opposite of squaring, which isn't dividing by 2. So you'd figure out what number times itself. So negative square root of 1 is negative 1. The plus or minus the square root of 4 over 25 becomes plus or minus 2/5. And this one, the square root of 12 and 25/100 became 3.5. And it's just positive. It's not 3.5 or negative 3.5. It didn't ask you to find both. So when it doesn't ask you to find both, you just do the positive one. The last one was the part that I thought would be the trickiest, and that is using the order of operations to evaluate expressions. The square root symbol, the radical sign, is considered part of the grouping symbols, or that parentheses stage, but I like to call it grouping symbols. So you always take care of that first. So this is 5 times the square root of 36 plus 7. So you get 5 times 6 plus 7, and you follow the order of operations from there. And this one we talked about how if I tried to do the square root of 18 and I tried to do the square root of 2, I wouldn't get these nice whole numbers or perfect squares that would be easy to work with. In fact, they wouldn't even be terminating decimals. So I then said, well, look at that. 18 over 2, does that simplify into anything? And it simplifies into that whole number 9. And so when I do that, I take the square root of 9, I get 3. And now this fraction that's in the front and both of these turn into the very simple answer of 3 1/4. This one we talked about how whenever you see this radical sign and square, they say take the square root and then square it. You're basically canceling each of these out, because the square root of 81 is 9, and the 9 squared brings you right back to 81. So whenever you see the square root symbol and the exponent 2 next to each other or around the same number, you can just jump from here to 81 and then do the subtraction. And you guys worked on these in class. A bunch of you forgot that this meant multiplying 3 times the square root of 25. A lot of you said 6.4 or 6 4/10 for this one because you simplified 28/7 perfectly to 4, but then you forgot to do the square root of 4. Just because you simplified the fraction didn't take care of the square root. So unless you say, I've done the square root in my head, you can't get rid of the square root symbol. And this one is that example of the radical sign and the exponent 2 together. They just cancel each other out. And then you can use this information now to solve equations that have the exponent 2 in there, because the opposite of squaring is to take the square root. And you know how to solve equations that involve multiplying. You divide, and then you would take the square root, and you would get to the answer. And they're going to give you 2 out of the 3 pieces. They tell you what to use for pi, 3.14, and they gave you the area. They're always going to ask that you simplify pi to 3.14, even though that's not its true value, because we can't get a true value for pi unless you have the pi symbol on your calculator. But they're going to make sure to give you numbers that if you use 3.14, that you're going to get a nice whole answer at the end. And we did this one together in class just to get through the time element that we were facing. But notice it came out to a nice whole number using 3.14 for pi, and they'll give you any formula that you need to answer the question. So that's a quick glimpse at square roots.